Hello, welcome to everyone in this video. This is our lecture number 1 for mathematical methods for semester 3. Okay, actually, we want to follow the syllabus of Calcutta University for Physics Honours for semester 3 of mathematical methods. In this lecture, we want to discuss the phenomena that is the singular point of a second order linear differential equation and their importance. I want to discuss in this lecture of this, that is the singular point of second order linear differential equation. You need to know about the second order linear differential equation. After that, you need to know the singular point and their importance, right? So we will be discussed about this factor in this lecture, right? So you can see this is the syllabus for the semester 3 of the University of Calcutta, mainly mathematical methods, physics 2. You can see here this is a Fourier series and then Frobenius method and special function. I want to discuss this portion in this lecture, that is the singular point of second order linear differential equation and their importance. This portion we want to discuss in this lecture. I will start this series of lecture from this point, and in the next some after some lecture we will be come back to this Fourier series, but at the starting I want to start from this portion, right? So you can see this is the total syllabus, that is the sum special integral, then integral transform, and this introduction to probability and the partial differential equation. These are actually the total syllabus of this mathematical methods for the semester 3 of Calcutta University Physics Honours, right? So let's start with this portion, that is the Frobenius method and the special function. Actually, for the starting Frobenius method, you have to know about the differential equation, then what is the first order differential equation, then second order differential equation, and what is the singular point and its importance. So before starting the Frobenius method, you need to know about all these things, right? So you can see, you know all about this, that a differential equation is nothing but that is the equation which consists the derivative term, the equation which consists the derivative term, that's like dy dx or d2y dx or del y dx. You know this is the partial differential equation. This type of equation is known as the differential equation. And partial differential equation, you know where this type of equation actually arises. The function, this phi is function of x y z. There is a wrong written here, you can check here, that is this is del 2y del z square, right? So this type of equation where this function is depend more than one, this phi is depend on x y and z, that's why this is the partial differential equation. And ordinary differential equation which is like that, that is the derivative, this is the function of only one function. This kind is varies only with the time interval, with the change with this time, that is this is depend only one function, that was this is the ordinary differential equation. And this is depend more than one function, that's why this is the partial differential equation. So at the conclusion we can say the differential equation is this equation where there is a differential term, that is partial derivative term or the ordinary derivative term must be included in this equation, is the differential equation. Clear? After that, you need to know about the homogeneous differential equation and non-homogeneous differential equation. You can see here in this equation, this can be written as the 1 by 1 plus dy dx. That means you can see that is this can be written in this ordinary form. In general, you can see this is the power of this x or y, that is the variables x and y both are the variable here. You can see here this is the power is 2, right? So if this can be written in this form, this is called homogeneous equation. If this not can written in this form, this will be 0 in case of homogeneous, and this is the function of x in case of homogeneous equation, right? So this is the basic funda, that is homogeneous is the order is the same everywhere, but in this non-homogeneous, sorry, inhomogeneous equation, this order is not same here. There you can see this order is 1 and here this order is 2, that's why this is called inhomogeneous ordinary differential equation, because there is a only dy dx, there is no partial derivative, that's why this is ordinary differential equation. This is your homework, try to it, that is the h cross squared by 2m d2 psi del x square plus v of psi e psi. In the quantum mechanics you will be learn about this equation. This is the famous equation, that is the time independent Schrodinger equation. For this equation you try to know about which is the homogeneous or non-homogeneous. Try to yourself that this is homogeneous or non-homogeneous, homogeneous or non-homogeneous. You try to solve this to just know about is homogeneous or non-homogeneous, and comment in the comment box homogeneous or non-homogeneous, right? So this, sorry, inhomogeneous, homogeneous or inhomogeneous. So try to know about the homogeneity of this differential equation, that is the time independent Schrodinger equation, which is the famous equation in quantum mechanics, right? After that, you need to know about the order and degree. Order, you know, the highest derivative appearing therein is the order, and degree, the power of which the highest derivative appear. For example, suppose there is 3 d2y3 x cube whole to the power square plus dy dx whole cube and plus y equals to 0. For example, here you can see easily that is the order is nothing but the highest derivative, which is 3. And what is the degree? Degree is the highest power of the highest derivative. The power is the highest derivative is 2, so degree is 2. Very simple. Suppose you have a equation like that, that is the whole to the power 3 by 2 plus dy dx plus y equals to 0. So what is the order? Order you can see easily, that is the 2. And what is the degree? Degree. So you need to turn into the linear form, so this degree will be 3. You need to square in the total term, then after that you will be get the degrees 3. I think clear. Now say about this equation. Suppose you have a equation like that, that is the sine of dy dx, like that. What is the order and what is the degree? What is the order? We can see there is maximum order is 1. Okay. And what is the degree? Degree is also 1, right? Because in this expression we will be get the order term, but this order will be like that. Now what about this equation? Suppose sine d2y dx square plus dy dx plus y equals to 0. Suppose this is your differential equation. Do you know what will be the order? Order will be 2. There is no problem. Sorry, this is 2. Sorry. Then what is about degree? If you expand this sign expansion, there is an infinite series. So degree is not not be obtained, or not be fixed, or cannot be determined. Cannot be determined. Clear? Here we cannot determine the degree because this will be the infinite series, and you know degree is nothing but the highest power of this derivative, but we cannot get the highest power. This will be infinite series, that's why we cannot determine the degree of this equation. This is the more an exceptional case. You can remember this one, right? So this is that one, and this is the most important. Clear? Go to the next one, that is the first order differential equation. First order means the derivative will be like that. So this is the formation of the first order differential equation. This can be solved by the separation of variable. Just separate out these two function, x function and y function, then integrate, that is p of x function of x dx and q of y dy. Just integrate, then you will be get the solution. Exact differential equation, if this can be written as d phi, so just phi is nothing but integration d phi. Just integrating of this equation, you can easily find out this equation. And the linear first order differential equation, this is the linear first order integration. The integrating factor, you can find out the integrating factor, and after multiplying this integrating factor, the solution will be d of y into this integrating factor equals to q of x q sorry, q of x into the power integrating factor into dx will be the solution. I think you know about this solution because this already discussed in the first semester mathematical method. So you all know about this solution of the first order differential equation. But in this semester we know about the second order linear differential ordinary differential equation. Ordinary differential equation means the y is function is only one dependent function, that is the x. The y is depend only x, right? That's why this is called ordinary differential equation. And second order, this is the second order, right? So this is the general form of second order differential. Sorry, this is the second order linear differential equation. Now, for second order linear differential equation, you need to know about these 2 points, that is the ordinary point and singular point. What do you mean by ordinary point and what do you mean by singular point? If this differential equation form into this general form, after that check at this point that x equals to x naught at any value of x. If these two are, that is the coefficient px and qx are finite, then this point, that is the x equal to x0, is point known as this ordinary point. This x0 point is known as this ordinary point. What about singular point? If at that point these both or any one of these coefficient, any one or both, or oblique and means these two one or these, right? So any one of these coefficient or both of these coefficient are infinite or diverge, then this is called singular point. This singular point again categorized into two terms, that is regular singular point, or this is also called essential 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 singular point, or regular singular point, or essential singular point, or irregular singular point. Regular singular point means if we multiply this x minus x naught, which is actually diverge, x minus x naught into px and x minus x naught square into qx are finite at that point. If these two are finite, these are infinite and these are finite, right? So this condition will be satisfied at first, then this condition satisfy. If these two conditions satisfy, then this is called regular singular point. If these and or these are the infinite at that point, then you will be called the regular singular point. I think clear. This slide is very important. You note down these things for finding the singularity check of any differential equation, second order ordinary differential equation. It will be helpful for you to finding the singularity of any differential ordinary differential equation, right? So go to an example. Suppose if you wants to know about this example, suppose there is an example. Sorry, if you take an example like that, d2y dx square plus 1 by x into x minus 1 dy dx plus 1 by x minus 1 whole square y equal to 0. For example, this is an example. So this is the p of x and this is of q of x. So p of x will be infinite when this will be 0, that x equals to 0 and x equals to 1. These two are our singular point. Now this singular point is regular or irregular. For that you need to multiply that x minus 0 into p of x. So this will nothing but x into 1 by x minus 1 at x equals to 0. So this will be cancel out. This is nothing but minus 1. This is finite, and x minus 0 whole square q of x equals to x into x minus 1. No, q of x whole square x equals to 0. If you put this x equal to 0, this is also finite. So this will be the regular singular point. Regular singular point. I think clear about these things. Next one, what is the importance? So some important property. If there is a two solution, if c1 y1 and this is the another solution, then their summation also will be a solution. You know the superposition theorem about the electrodynamics. And nonlinear differential equation, this equation which cannot represent this linear function, that is this is the linear equation. If this quantity is added up, this is called nonlinear equation. For example, Bernoulli's equation. Now you need to know about the singular point. What is the importance? Actually, if you know the singular point, the solution will be the converge, right? So we actually interest about the ordinary point. There is, you can see, that is the, we can solve this any differential equations for the ordinary point and the regular singular point. These two are the important because these are the finite at a particular point. So that's why you need to know about the singularity of any differential equation. So you need to know sorry, about the any differential equation to find out the regular singular point. Sorry, if this point is ordinary or regular singular point, so you can easily find out this, that is the easily find out this solution, that is the Frobenius method. Using the Frobenius method you can find out the solution very easily if this point is okay. For example, if you take this an example that is like that, if we take this example, that is, for example, that is x d2 y dx square plus c minus x dy dx minus ay equals to 0. Okay, so this is nothing but d2y dx square and 1 minus x, so c minus x, right? No problem, c minus x, x dy dx minus a by x y. Okay, so this will be p of x, that is c minus x by x, and this is q of x, that is minus c by x. Okay, so this will be, you can see, at x equals to c, you can see at x equal to c, p of x equals to 0, and if this is a, no problem, write down a, and q of x equals to 9 minus a by c. So these were finite, so this point is ordinary point, ordinary point. Okay, no problem. And x equals to 0, you can see p of x tends to infinity, q of x also tends to infinity, since these two are infinity, so this is the singular point, singular point. Now you need to check the singular is regular or irregular. For that you need to multiply this x into p of x, that is x equal to 0, so this is nothing but c minus x at x equals to 0, so this is c, this is finite, right? And in x square q of x, this is also this multiplies, so minus ax, that x equals to 0, so this is also finite, since these two are finite, so this is the regular singular point, regular regular singular point, regular singular point. I think clear about this concept, that is the regular singular point and irregular singular point and ordinary point. Okay, you can see here, this is the regular singular point at x equal to 0, irregular singular point at infinity, because if you take x equals to infinity, these two are also this is infinity, if you take x equals to infinity, if you check this x equal to infinity, this is the infinite, so that's why this is the singular point, and if you take this square and take the calculation, you will be get this will be the irregular singular point. Okay, so this is your table for different important differential equation, that is legendary, Basels, this is another important, and this Hermite, this Hermite, Basels, and legendary. This our syllabus. This will be discussed in details in the upcoming lecture. This is actually your homework. Do this. Find out this regular singular point and irregular singular point for this differential, especially these three equation. For these three equation, you must find out the regular singular point and irregular singular point. This is another homework you will be must do yourself, right? So that's for that's it is that's for today. This is all about me. And this is my contact details. You can connect with me with this Telegram channel to connect with me to get the notification for upcoming lectures and all these things. This is my YouTube platform. This is my YouTube channel details. Go to this channel. You will be get the defined physics related lectures. If you learn something from this video, let's like this session. Share this video to your friends. Either he or she also get benefit from this video. Subscribe this channel if you new in this channel. And there's already subscribed. Thanks for subscription. Press the bell icon to get the notification of upcoming video. So take care. We'll meet in the next video as soon as possible. Thank you.